This is Mr. Anderson for Keller Community College. Today, our third of three parts dealing with complex numbers, the number I, which is the square root of -1. And we are going to do a little bit from problems 19 through 27. We're going to take a look at I raised to different powers, and you're going to find a pretty cool pattern here. First of all, let's remind ourselves that the I is the square root of -1, and that's going to start us out here. Now, if we have I squared, this means that I squared is the square root of -1 times the square root of -1. And any number times itself under the radical, so the radical of this and the radical of this just makes -1. Because that would be, if I wanted to compute this here, this would be -1 squared underneath the square root. And the square root of that squared is itself. Now if I go to I cubed is going to be the square root of -1 times the square root of -1 times the square root of -1, which is, as we found out, that this chunk here was equal to -1, and therefore we have the square root of -1 times -1, so this is just -I, because this is just, the square root of -1 is just I. So I cubed is -I. Now, what if we get to our I to the fourth power? Now, I can write, with my I to the fourth power, I can write square root of -1 times square root of -1 times square root of -1 times square root of -1. But since I know that my I squared is -1, this is -1, and this is -1. So I to the fourth power is -1 times -1, which is 1. Now, one of the cool things is that if you have a graphing calculator, you actually have the ability to make an I. And to do so, you'll go second and then hit the decimal key, and then you have your I. And I on the calculator is just I. Now, when we go to I squared, you can see that this will actually follow suit with the experimentation that we found. The I squared is -1. And therefore, if we go to I cubed, the calculator does the work for us and tells it's -I. And then I to the fourth power is just 1. So let's move this over here a little bit in place of the room that we have done. Oops, I think it's going to be easier if I put the calc here. Okay, so let's go now get to my screen draw again. So you'll notice that I did put the square root of -1 here, but you can see that now I is equal to I squared is equal to -1, and I cubed is equal to -I, and I to the fourth is 1. Now I to the fifth, I can write I to the fifth like I to the fourth times I, and since I to the fourth is 1, I to the fifth is just I. I to the sixth can be written as I to the fourth times I squared, and we know I squared is -1. 1 times -1 is just -1. You're going to see the pattern emerge here, because this is I to the fourth times I cubed, and so I cubed is -I, and you can see that I to the fourth is just, or I to the eighth is just I to the fourth, and I to the fourth, 1 times 1 is 1. So you see this pattern here. The pattern is that the top is matching the bottom. But more importantly, this is a cycle. And the cycle of powers of I go I, -1, -I, 1. I, -1, -I, 1. So when I have a problem like I to the 32nd power, I have to think, like, there's ways that the 32nd power has been made into I to the fourths. So I'm looking for a multiple of 4. So for example, I to the 32nd power can be written as I to the 4. How many times? I can write this 8 times. So this is I to the 4th to the 8th power. I to the 4th is 1, so 1 to the 8th power is just 1. Now I to the 15th, this was easy because it was divisible by 4. But I to the 15th, I think to myself, okay, think of all the 4s, multiples of 4. And that's I to the 12th, because I to the 12th is 4, 4, and 4. Now I need I cubed, and I to the 12th, since it's 4, 4, and 4, or it's I to the 4th to the 3rd power, and then it's I cubed, I to the 4th is 1. 1 times 1 times 1 is 1, which leaves me with I cubed, and for my chart here, it's going to be negative I. I to the 42nd power. Now this is I to the 40th power. Notice I've picked another multiple of 4 here, times I squared. Now I to the 40th is I to the 4th, which is 1, raised to the 10th power. So that's 1 times 1 times 1 10 times, which is 1, times I squared, which is going to be negative 1. A problem that's smaller like this is easier to digest, because this is I to the 8th times I, and I to the 8th is just I to the 4th squared. So that's 1 times 1 times I. The answer here is I. Here, this is negative 1 to the 6th power. It's best to split this up. Negative 1 to the 6th power and I to the 6th power. Negative 1 to the 6th power is positive 1. I to the 6th power is I to the 4th, which is also 1, and I squared. So 1 times I squared, which is negative 1. Your answer is negative 1. Negative I to the 71st power. Again, it's best to split this up. Negative 1 to the 71st power times I to the 71st power. The negative 71st power is going to be negative. The general rule for this is that if you have an even number, or an even power, the negative 1 will turn positive. If you have an odd power, you have 70 cancellations, and then the 1 left over is going to be negative. Okay, so now I to the 71st power. So I got to think to myself, okay, what is a multiple of 4 that gets me up to 71? Now, 80 is a multiple of 4, because 80 can be divided by 20 to get 4. So I'm going to have to rock back from 80. So 86, 82, I'm sorry, 76, 72, so close. 72, and let's drop it down to 68. So we got I to the 68, and then we have I cubed. Now since 68 is a multiple of 4, we can then make that just times 1. Any multiple of 4 up here is going to give us that 1 times I cubed. I cubed is negative I, so I've got negative 1 times negative I is going to be positive I. Okay, for number 26, I've got negative 1 raised to the 4th power and I raised to the 4th power. So negative 1 to the 4th power is 1. I to the 4th power is 1. 1 times 1 is 1. Okay, separate this again. 4 to the 3rd power and I to the 3rd power. I to the 3rd power is negative I, and 4 to the 3rd power is not 12. It's 4, 16, 64. So my answer is negative 64. Remember, this is being multiplied there. I. All right, these are a little tricky, but the more practice you get, the better it becomes. All right, thanks for watching.